Yesterday we began Chapter 3 talking about measures of center. Today we'll talk about a couple more complex measures of center, and we'll also talk about what different measures of center can do to graphs in terms of skewness and where they get skewed and how we can read the distribution from there. Let's first of all start with a possibly new symbol for you. Some of you have seen this symbol, some of you haven't. It's the summation function. The summation function in the Greek letter sigma, the Greek capital sigma, it means to take the sum of all previous calculations. A couple of examples here below are how many of you have seen it before is the first green bullet, where you're starting with 1 and you're going up to 5, and you're finding the values of the function that's in front there, 3n plus 1. In other words, if I'm plugging in 1 for n, it's 3 times 1 is 3 plus 1 is 4. That's where I get the first value. Then I'll plug in 2 and I'll get the value of 7, plug in 3, get the value of 10, plug in 4, get the value of 13, and plug in 5 and get the value of 16. The sigma then means to have summation of all those values, so I'll add them all up to get 50. How we'll be using it mostly in this course is the second green bullet. We'll have the summation function and then a bunch of different things to sum. It'll be involved in many of the formulas, in fact all of the formulas that we're going to talk about today. First, let's talk about calculating a mean from a frequency distribution. It is possible to calculate the mean of a set of data given the frequency distribution. It might not be the exact mean, but it'll be very, very close to what the mean is supposed to be. The formula for this is we're going to let f be the frequency. So the mean, x bar, is equal to the summation of each frequency times its class midpoint, and then we're going to sum all those, and then that's all divided by the sum of the frequencies. Now the sum of the frequencies is the number of data points that you have in your set. That's very simple to find. The top part of the fraction will not be simple to find. We will go over an example on the next slide. So here's an example. Let's say we're talking about college admissions essays. The chart there at the left talks about 5 different classes, and we're doing a word count from 0 to 9,999, so on and so forth. Hopefully you can see that the class width here is 10,000 words. So we have the word count and we have the frequencies. That's typically all you'll be given right from the get-go. What you need to do is the third column, which is the class midpoint. The class midpoints obviously are halfway in between each of the classes. Then what we're going to do is we're going to multiply columns 2 and 3 together. That's the frequency column and the class midpoint column. That's how I got the fourth column. So to start my calculation process, the first thing I'm going to do is add up the F column. That's the summation of the frequency column. If I've done that correctly, and I have, I get 186. That number is going to go on the bottom of the fraction in the formula. The top of the fraction is going to be the summation of my fourth column, the F times CM column. The frequency times the class midpoints. When I add the fourth column up, I get 2,959,907. Then all I want to do is add up, or excuse me, not add up, but divide the top number and the bottom number. And that's what I have here. X bar is 2,959,907 divided by 186. Therefore, I get a mean of 15,913 and a half words. If you were to actually see the entire data sheet and did the actual mean, you would see that you would be very, very close, if not exactly on point. The other type of complex measure of center is the weighted mean. When we have values that possibly have different weights, we have to compute a weighted mean. The formula for that is below. We're going to let W be weight in this case, and let X be the corresponding value to that weight. So the mean is going to be the summation of all of the weights times the corresponding values divided by the summation of all the weights. A classic case with this particular calculation is GPA, and that's what we'll do on the next slide. So let's take a look at how GPA is calculated. For this particular college, we have the grading system of 4 points for an A, 3 points for a B, 2 points for a C, 1 point for a D, and 0 for an F. If Molly gets these 5 grades as her semester grades, let's see how we can calculate her GPA. First, we'll start out with the top of the fraction. That's the summation of the weight times the corresponding value. Now, Molly got an A in her 3 credit class, so she gets the number of credits, which is 3, times the value of the credit, which is 4 in this case. Excuse me, not the value of the credit, but the value of the grade, which is 4 points in this case, so 3 times 4. The second A is a 4 credit class, so she gets 4 credits times the point value, which is 4. The B is a 3 credit class, so she gets 3 credits times the 3 points. She got a C in another 3 credit class. That's 3 credits times 2 points for the C. She got an F in the 1 credit class, so it's 1 credit times the number of points, which in this case is 0. Then after doing all those calculations, I'm going to add them up. That's the summation function. When I do that, I get 43. The bottom of the formula will be the summation of all the weights. In this case, we're talking about credits of a course. So 3 plus 4 plus 3 plus 3 plus 1 gives me 14. To calculate the GPA, I take the 43 points that she earned, divided by the 14 weighted credits, and that's where I get my GPA of 3.07. Skewness is what we talk about in terms of the graphic distribution. When data is symmetric and there is 0 skewness, that's when you have mean equal to median equal to mode. It's the perfect bell curve. Negative skew is when it's skewed to the left. It's a little bit of a misnomer because when you think skewed to the left, you're going to think the majority of the scores are on the left. That's not true. Your tail of the scores is to the left, and your big bump, if you will, is to the right. Statistically speaking, that means our mean and median are less than the mode. Positive skew, when it's skewed to the right, means you have a longer tail to the right, and that your bump is to the left. Statistically speaking, of course, the mean and median are now greater than the mode. One of the more important things that we can talk about here, however, is that the mean and median cannot always be used to identify the shape of your distribution. Just because we might be able to tell skew doesn't mean that we can tell distribution. There are different levels of skew that we need to consider. Here's a couple example pictures of what skews look like. The one to the left, filled in with blue, is your 0 skew. It's perfectly symmetrical on both sides. Ideally, that's what you want your data to look like. Positive skew is again when we have most of the scores to the left, and you have a long right tail. The opposite is true of negative skew, as you can see below that. Your homework in this section is textbook pages 97 to 98, numbers 29 to 35 odd.